Hello, dear students. I am Samir Velankar. I welcome all of you to this video on the topic linked list data structure, in which we will be learning complete program on singly linked list operations. In this video, I will teach how to create a singly linked list, how to display a singly linked list, and also how to delete some node of a singly linked list. Now, in the junior semesters, maybe in the third or fourth semesters, you have gone through all these programs on singly linked list and doubly linked list operations. Now, to tell you that this program is pretty lengthy, as you will see, it has a long list of code. But my appeal to all of you is, with immense patience and attention, you just go through each and every aspect of this program, because after all, in the examination, gate examination, they give a short code, a very small code of this large amount of code. They will just give a snippet of the code and they will ask you a few questions on singly linked list. So it's very important to understand pointer operations. How do you pass pointer to a function? How do you manipulate a linked list? We want to create a linked list, by the way, in such a way that a node of a linked list, suppose this is a node of a linked list, is going to store a single integer value. Let's make the things very easy. And it will have a pointer called next. Every node will have integer data. Data will be simply an integer, and there will be a pointer to the next node. Suppose the next node in the memory is again storing some integer value and has a pointer called next. Then this next will again point to the next node, which stores integer data, and so on. The list goes on like this. All right. We will also have a header pointer called first, which will always point, this is a pointer which will always point to the very first node of the list. So suppose the address of this very first node is 1000. That is, the node, that is this structure, is loaded in the address or stored in the address at address 1000. Then first will literally store 1000. And imagine that the second node, which stores 20, is stored at base address 2000. Then the next pointer of the very first node is going to store 2000. And if the address of the third node is 3000, imagine, then the next pointer of the second node, which is storing 20, is going to store 3000. And this is the way how every ith node stores address of I plus 1th node. Now just imagine this list goes on and this is the last node, let's say storing 100. Then the next pointer of the last node is going to store a special value null. It indicates that the next pointer of the last node is not pointing anywhere. So the list ends here. So the list typically starts from the first pointer. First pointer will tell us where is the first node. Once we locate the first node, only then we will know where is the second node. Second node will tell us address of the third node, and so on. And the last node tells that as next pointer is null, the list ends here. So we are going to create such type of list. So any such program which creates a singly linked list typically starts with the struct declaration. Just check, the struct declaration has declared a structure called node. And every node will have integer data, int node, and a pointer called next. This next pointer can point to a node itself, and node is a structure. So think of this. Suppose I have a node in the memory. This is structure node. This can store data. Data is of type integer, and it has a pointer called next. Now, as next is a pointer, it can store address. Address of who? Whose address can it store? Any node, same type of node which stores data and which has next. Please try to understand, next cannot store address of an integer, next cannot store address of a float. Next is a pointer and it can store address of a node structure. That's why the declaration is struct node asterisk next. So here comes the question, very interesting question. Suppose the node which I am right now marking, this node, is stored at address 1000. Then can this next pointer, the next pointer, store 1000? That means can the next pointer of the node point to the same node in which it is stored? Is this possible? Yes, of course. Because which kind of pointer is next? Next is a pointer which can point to any node. And the box which we are seeing is a node, isn't it? So it can definitely point to the same structure in which it is stored. Or it can point to any other node, isn't it? It can point to any other node. So this next pointer of the very first node, which is located at address 1000, can point to the second node. If the second node is at address 2000, then the next pointer is going to store 2000. So that is the structure declaration. Every node stores integer data and has a pointer to next node. Then after that we have written insert function, which will insert only one node in the linked list. I repeat, suppose you want to insert 1000 nodes in the linked list, then the insert function at a time will insert only one node. So you will have to call the insert function 1000 times from the main if you want to insert 1000 nodes. There is no for loop. There is no structure like for loop that insert 1000 nodes at once. Anyway, so this is insert function which inserts one node at a time. Then we have written display function. The display function is going to display all the nodes from first to last. So the data stored inside the nodes will be displayed by the display function. After that, we have written a function called delete node. Delete node function will delete one node at a time. We will tell delete node which node we want to delete, and delete node will delete that node. After that, we have written main. Okay. So now the entire story of course starts from main, isn't it? So I have directly jumped to main, and let's execute main and see what happens. In main, I have declared a pointer again. Check that first. Sorry for semicolon is missing here. Check that first is a pointer which can point to node. So in the memory, there is a pointer called first, and this pointer first can point to node, but there is no node yet in the memory. Remember, a node is a structure which stores data and next. There isn't any node. We have not created any. Note that this declaration, remember the structure fundamentals that we learned in programming. Note that this node that we have declared is only a data type. We have not created any instance, any variable of node type. So in main, we have declared a pointer. The pointer can point to a node, but node doesn't exist. The next line is initializing the pointer to null. This pointer first is literally storing a null value. That means first isn't pointing to any node. By the way, after that, we call the insert function. Our aim is we want to insert a value 10 in the linked list. Well, what do you mean by that? Is we want to create a node now. Yes, we want to create a node, that is structure node, which will store integer data as 10. This data should be inserted in the linked list. So what is the call to insert? You see, initially, those who are not very comfortable with pointers and pointer to pointer will find it bit difficult, but I promise, this is my word, that after one or two executions of insert and discussion of this, you will be very comfortable with what do you mean by passing a pointer and what do you mean by pointer to pointer. But just observe the call to insert. How is insert called, you watch? Insert is called by passing address of first. Now you all know that first is a pointer, but the pointer itself will have some address, isn't it? Let's imagine that the address of this first pointer is 500. That means the byte at which the first is located is 500. Then we are passing that address to the function insert. Second parameter we are passing is a simple integer value, that is 10, which we want to insert in the node. So let's come to insert function now, because the function is called. The insert function, observe, is having void as the return type, so it is not going to return any value, but it is having a pointer to pointer. There are two asterisks written before. What is the meaning of this? Note whose address have you passed here to the function. You have passed address of first, but first itself is a pointer. You are passing address of a pointer. That means there will be a pointer which will point to first itself. Let's see the diagram again. Up till now, we have a pointer called first. Now this first is located at 500, we assume, and this first is currently null, and we are passing address of first. Now address of first will be copied in a pointer called p. P is a pointer, not the parameter. P is a pointer, correct? And what does p store exactly? Address of first. Note that address of first is literally 500. That means p is going to point to first, because it is storing address of first, isn't it? So p is clearly pointer to a pointer. First itself is a pointer. So two asterisks will be needed. I hope you are understanding. I repeat, p is storing address of a pointer. See and first here. So p will be pointer to a pointer. That pointer is first. And the second parameter is integer x. This should be int x. Okay, int x. Just manage this. The second parameter is int x, and you notice x is 10. We pass the second parameter as 10. All right, let's execute the code now. In the code, there are two pointers that we have declared to start with. Note that temp and a both are pointers which can point to node. That means in the memory, I am having one more pointer called temp. Notice this temp can also point to a node which stores integer data in next pointer. And there is a pointer called a. A is also a pointer which can point to a node. But there is no node yet created. I repeat, we have not created any node which can store integer data and next pointer. These three are simply pointers which can point to a node. Now the next line. This is about call to malloc. And we are allocating memory for size of one node, one structure node. So somewhere in the memory, a node structure gets allocated. The amount of memory that will be allocated for this structure will be exactly equal to the amount of memory required to store data. Remember, data is integer and next pointer. Whatever that amount of memory is, maybe data is integer, so it consumes 4 bytes, maybe, and next is pointer, this also consumes 4 bytes. So 4 plus 4, allotment done will be exactly 8 bytes, isn't it? But that depends on the platform machine on which you are working. Importantly, the amount of memory that will be allocated will be equal to the size required by one node. Size of struct node has been written. And whatever memory has been allocated, the address of that byte where the memory was allocated will be literally stored by the temp pointer, you note. On the left hand side, the temp pointer has been written. So this is so easy. Temp pointer should store address of newly allocated bytes. Suppose the newly allocated bytes is at 1000 address, 1000, then temp is going to store 1000. That means temp will point to the node. And you also notice this node does not have any name. This is a structure, but it has no name. If there was a name, then we would have used dot notation. Like if E1 was the name, we would have written E1 dot data, E1 dot next, but there is no name. If there is no name, but still we have a pointer, isn't it? Temp pointer is pointing to this node. So we can access these members by writing temp arrow notation. I hope you remember the structure topic which was held just 5-6 videos back. Temp arrow data and temp arrow next will give you access to the members of the structure. Okay, but it's our responsibility that after we allocate, once we allocate the memory, it is so important that you check whether the memory was allocated or not. Well, if the malloc was failure, it was not able to allocate the memory due to some reasons like memory is full, then the pointer temp written on the left hand side will be null. So if temp is null, then you print cannot allocate memory and you exit the program. Definitely, if memory is not present, what's the sense in continuing the program? This exit will simply terminate the program, printing that memory deficiency is there. But assume that right now temp isn't null and temp is very well pointing to 1000 as you see. So the memory was allocated, and throughout we will assume that memory is allocated. We will never assume that the memory is full. So we will assume that this never happens. Okay, so the next line runs now. Temp arrow data should be x. What is x? We passed 10, isn't it? 10 to the function. So the data at the first node, this temp arrow next, sorry, temp arrow data will become 10. That was our aim. We wanted to store 10 inside the node. And the next line written is temp arrow next. Remember, this next is a pointer, should become null. So temp arrow next is now null. Why have you made this next null? Actually, this next is responsible for pointing to next node, isn't it? Some next node, maybe which stores 20. But there isn't any node right now. This node is alone. So how can it point to any next node? So it is good that you say that next you better be null right now. Maybe when some new node joins after you there is a follower, let's say 20, then you should not be null anymore. We will change your value and next you will better point to the next node like 20. But right now at least next has to be null. All right. What's the next thing we have written? Now we are asking if asterisk p is null. Now you observe this is so important, pointer basics. If p points somewhere, note the cursor, if p points somewhere, then what does asterisk p mean? Asterisk p mean value to which it points. That means here asterisk p is same as first, same as first. If p points to first, then asterisk p means value of first. So actually by asking if asterisk p is null, we are indirectly asking if first is null. You notice this if and this if asterisk p is null and if first is null are both same. But then there might be question in your mind, why don't you write directly if first is null? Why are you writing if asterisk p is null? Come on, you know the basics of programming in C, and you know that the first that we have declared, the first we have declared is in main. Check where is this first variable declared. It is declared in the boundary of main. Observe the brace open. So this first can be used only inside main. It cannot be accessed outside main. You call such variables as local variables or auto variables, isn't it? But then what you did is you passed the address of first. Once you pass the address of first, it was copied in the pointer to pointer. And now through pointer to pointer, through P, you are reaching first. So first is still accessible, but not directly. You can't write first equal to null. You will get error. Error will be first not available because first is available only in main. But first is indirectly available through asterisk P. I hope you got this. I hope you got this. Okay. Now, is asterisk P null? Really? Yes, it is. Check asterisk P means first, isn't it? And first is null. Yes, first is null currently. Observe. That's how we have initialized first. The value of first is null. So hence the if is true. If is true. So this line will run which I am underlining. Asterisk P equal to temp. Read it like first equal to temp. Remember asterisk P is same as first. First equal to temp means first will point wherever temp points. Read it like a layman. These two are pointers. Asterisk P means first. Correct? First is a pointer. Temp is a pointer. So first equal to temp means first will point wherever temp points. So first will literally point to the same node where temp points. That means first is no more going to be null. First is going to be 1000. First becomes equal to temp. Temp is 1000. So first is 1000. It means first also will point to the same node where temp is pointing. Okay, after the if becomes true, else doesn't run, obviously. So this else portion will be skipped. Oh, I'm so sorry. This is not the else portion. I misread it. Okay. Where is the else portion? You see, this else portion starts from here and it goes on till. I'm so sorry. Wait a minute. This else portion starts from here and it goes on till here. This entire else is skipped because if was true. And what remains is end of insert. Wow, congrats. We have finished the first execution of insert. It was so easy. What was the summary? Create a new node using malloc, call it as temp, call the new node as temp, store the data using temp arrow data and temp arrow next notation. Temp arrow next will be null because new nodes next will be null. There are no followers. And then ask, is the header pointer first null? Header pointer means asterisk p. Asterisk p is same as first, isn't it? Is the header pointer first null? That means header pointer is not pointing anywhere. Then ask the header pointer to point to the new node that is first equal to temp and simply skip the else because if was true and end the insert. Some cleaning work should be done. Insert has now finished. So stick to fundamentals. When insert is finished, the temp pointer will be deleted. What do you say? Do you understand what I am talking about? Because temp pointer was created inside the function. Even a pointer will be deleted. Note that a was not at all used, isn't it? This a pointer was declared in the function, but this time it was not used. Maybe in the next run of insert, next call to insert, a will be used. Also, temp and a is deleted because they were locally declared inside the function. What remains? Oh, and of course, p is also deleted, isn't it? Because p was the parameter of the function. Any local parameters and local variables are deleted. So what are we left out with when we return back to main? When the function ends, we are having a node, perfectly node stored at 1000, which stores data 10 and next pointer is null. And we have a first pointer whose address is 1000, who stores 1000 and points to the node. Very neat and clean linked list we have got. So let's return to main. This first insert function is successful, isn't it? It has inserted. What is the picture now? What is the picture? In the memory, we are having first pointer and we are having a node. Only one node was created. Data stored is 10 and next pointer is null. And maybe the address of this node is 1000. Address is 1000. Then first is literally storing 1000. We have loaded the address of first node in the pointer first. And don't forget the pointer itself has address like 500. All right, this is the linked list we are having. Now let's call insert again. Our aim is we want to insert one more node. Let's say the data at that node should be 20. So give me the summary. What are we going to do? What are you going to do? You will create a node, new node, which will store 20 and next will be null. And then you will talk about how to adjust the pointers, how to connect them. Okay, so what are we passing to this insert? Let's see. Address of first, isn't it? Literally we are passing address of this first pointer, and address of first pointer is 500. But notice we are passing address of a pointer. So the receiver end, we should have pointer to a pointer. So the parameter will be pointer to a pointer and second parameter is int. I hope you are getting used to this. So let's go to insert again. The insert function. Note insert function is having pointer to a pointer. So never mind, I will draw the list again over here. We are having a node which stores 10 and next pointer is null. We assume that the address of this node is 1000. So first literally stores 1000. First itself is having an address 500 and that address has been copied in a pointer. And this pointer will literally store 500. So P will point to the pointer first. Now onwards, Asterisk p means value to which the pointer points, and asterisk p is same as first. Remember, so in the code, if I write asterisk p anywhere, it is nothing but we are using first. Okay. The second parameter, mistakenly I wrote integer here, should be int x, and this x, all of you know, is 20. Let's start. Now in the memory we will have two more pointers, temp and a. Both are pointers to node structure. That means in the memory there is temp pointer created. It can point to any node, and there is a pointer created. It can also point to any node. Next line. Let's allocate memory for a new node, and temp, left hand side pointer temp, is going to store the address of that newly allocated node. So somewhere in the memory, new node is created, maybe at address 2000, and temp literally stores 2000. Address of the newly allocated memory, temp points to this 2000. Now there is no name to this node, remember, but we can still access data and next using temp arrow data, because temp is pointing to this node, and temp arrow next. So that's what we have done in the next line. Of course, we are not assuming that there will be a failure in allocation, as I said few minutes back. So this if is false, we assume. So temp arrow data is 20 because x is 20 and temp arrow next is null. So filling up this temp arrow data is 20 and temp arrow next here will be null. We have made temp arrow next null because there is no follower of 20. Of course, later on when there will be a new node, maybe which stores 30, we will say next of 20 you can't be null anymore. You have to point to 30, isn't it? But right now 20 doesn't have follower. Now what? Now we will ask if first is null. Oh, look at that. I don't even care reading this as asterisk p now, because we know asterisk p means value to which p points, and that's first. So we are asking if first is null, which is false this time, because first is storing 1000. It is very well pointing to the very first node. Please try to understand. So this if is false. So we are going to land up in else. I hope you are understanding. This else will run. Let's see what the else is supposed to do. What else will do, else will search in the current linked list, whatever is the linked list, where is the last node. Of course, here it is so easy to see. You will say, sir, last node is 10 because last time we created only 10. But if it was a very long list, then this else portion, has a responsibility of reaching the last node so that last node can be attached to the new node. Oh, let's see what I'm talking about. Let's see. Let's read the first line in the else. First line in the else is A is equal to first. Asterisk P is same as first. So this is pointer equal to pointer. That means A should point wherever first points. A is a pointer, So A will point exactly to that node where first points. So we have started A with the very first node. And then we will go in a while loop. We will ask, while A arrow next is not equal to null. See, if this condition is true, if next is not null, only then we will enter the while loop. But you observe currently A arrow next is null. You observe this A, check the mouse cursor position, A arrow next, this next, where the mouse is, not equal to null is false. A arrow next is null, isn't it? So the while loop straight away breaks because the while condition is false. What is the conclusion is we are at such a node, A is pointing to such a node, which is the last node, because you know that the next pointer of the last node was made null. Okay, while loop has stopped and there is only one line now, which I am underlining here. Check the code, I am underlining that A arrow next should be equal to temp. This is again pointer equal to pointer because next is a pointer. We read this as A arrow next should point to the same node where temp points. A arrow next points to the same location where temp points. So A arrow next, check this next, will point to the same node where temp points. So A arrow next won't be null anymore. Are you understanding? It won't be null anymore. But a arrow next will point to the same node where temp points. And where is temp pointing? Temp is pointing to 2000. Are you understanding that a arrow next, this a arrow next, will literally become 2000? Come on, because we have said it should become equal to temp. Temp is 2000. So a arrow next is 2000. So this next pointer is storing 2000. That means it will point to the address 2000. And after that, else ends, and after that insert ends. Oh lord, we have finished two executions of insert, and notice we have got two nodes. But wait a minute, before we go back to main, let's see what C does. C will clean temp. Temp was temporarily created. It will clean A also. These were locally created. It will delete these pointers. Isn't it so? It will delete these pointers, and it will delete P also, because P was the local parameter. Pointer to pointer was a local parameter, isn't it? And look at the picture that we are having in the memory when we go back to main. This is extraordinary. We are having first, which is still pointing to 1000. I'm so sorry for this. Many times it happens. Just manage this. First is still storing 1000, address of the first node, correct? And the first node now knows the address of the second node. And second node says, that is it, I am ending the list. Too good, isn't it? Too good. Okay, let's get back to main. Okay, in main we have successfully completed second insert call. What will be the third insert call now? Now many students in the classroom, say, sir, enough is enough, we have understood it. But the discussion of this repeatedly, maybe although this is a video lecture, discussion of this repeatedly throws immense illumination light on the knowledge of the code that we have written for singly linked list. So let's continue. Let's execute the third call. We are passing address of first and 30. Let's go to the insert function. Insert function. Never mind. I will draw. I will draw the current linked list that we have. The current linked list that we have is first, pointing to the very first node, storing 10, and next pointer is now efficiently pointing to the next node, storing 20, and next pointer of this 20 was null. We assumed that addresses were 2000, so next pointer which was stored in the location or the node 10 was 2000, and 10 was stored at address 1000. So first was literally storing 1000, and first itself was stored at address 500. Now you observe this pointer to pointer is going to store address of first. P is going to store 500. So asterisk P is same as first. Okay. And X which is int variable is now 30. So our aim is we want to insert 30 in this linked list. Two pointers as you see are declared temp and A, which can point to any node. So in the memory, there is a pointer called A and there is a pointer called temp. They can point to any node. Next line, allocate space. Allocate space for one node. So somewhere in the memory, a node is created again, which can store integer data, and next pointer, maybe the address is 3000. And temp, the left hand side pointer of malloc, is going to store 3000. So temp is pointing to the new node. Remember, this has two members, data and next. And we can access that members by writing temp arrow data and temp arrow next. That's what we have done in the next two lines. Temp arrow data equal to 30 and temp arrow next equal to null. So the data stored in the new node is 30 and next is null. Surely because this node 30 is not having any followers right now. But what do you comment? What do you comment about 20 is next? Observe 20 is next is null, but it should not be null. Tell me what should be the value stored by next of 20? I take a pause. What should be the value stored by next of 20? Yes, it should be 3000. Address of the third node should be stored by this next of 20. It should not be null, isn't it? So we want to do something about this. We want to change the next pointer of 20. How do you do that? Let's check the if now. We have if first equal to null. Well, first isn't null. First is very well pointing to 1000, as you see. First is not null, so we will land in the else. This else is executing now. Let's use the pointer A and we say A equal to first. So A will point exactly to the node where first is pointing. Now we will land in the while loop. We will ask while A arrow next is not equal to null. Is A arrow next not null? Let's see. A arrow next, this next of 10. Is it not null? Yes, it is not null because it is storing address 2000. So the while currently is true. As while is true, the statement in the while will run A becomes A arrow next. A becomes A arrow next means A will point to the next node wherever A arrow next is pointing. Check this. A should point wherever A arrow next is pointing. But where is A arrow next pointing? It is pointing to 20. So A should point exactly to the node where A arrow next points. Hence, A will move to the next node. A will no more point to the node where 10 was stored, but A will point to 20. I hope you have known how A traverses to the second node. Now A is pointing to second node. That is sorry. That is A is now storing 2000 because A became equal to A arrow next and A arrow next last time was 2000. Okay, enough. I hope you understood. Time to go back to while loop, and while is going to check while A arrow next not null. But listen, A arrow next is null now. Observe A arrow next. A arrow next means 20 is next. 20 is next is null. So this condition is false and the loop will break. The while, which was only one statement loop, will break. And when the loop breaks, the next line runs A arrow next equal to temp. Hello, you tell me, while has stopped. What do you know then? If while has stopped, you know that A is pointing to some node, such a node which has next equal to null. That means we are at the last node. We have located the last node, and once we have located the last node, we know that that last node has to be connected to the new node. So this statement out of the while loop, which is out of the while loop, A arrow next equal to temp, will now mean that A arrow next, which is null right now, should point wherever temp is pointing, isn't it? That means A arrow next will no more be null, and it will be pointing wherever temp points. And that is it. Else ends and insert ends. Congrats, we have finished the third execution of insert, and congrats that we have also understood how insert works. Believe me, this is too heavy what you have learned right now. And believe me, whatever we have learned right now and will be learning in detail will really help you to create any data structure. You will notice a subject like binary search tree, which is so difficult actually, will be peanuts for you. So meanwhile, I have deleted temp and A and I have deleted P also because these were local pointers. All right, then this is the linked list that we are having, isn't it? So let's go back to main, and we are calling insert fourth time. Oh, don't worry now. Surely don't worry. I'm not going to discuss this in detail, but I'm going to tell you in general summary of insert. Just see how the summary of insert goes. Let's say we are having first is pointing to the first node which stores 10, next pointer points to 20, next pointer points to 30, and suppose we have inserted many such nodes. Insert was called many times, assume, and next pointer points to 50, and next pointer of 50 is null. Just check this. And suppose the address of the very first node is 1000, then first is storing 1000, and first itself has an address, say 500. Now what if we call insert and we want to insert, let's say, integer, let's say 60 we want to insert. So what are the operations? We are not reading the entire function now, okay? P is now pointer to pointer, which will point to first. So asterisk P is same as first. We are having a pointer called temp, which can point to any node. We are having a pointer called A, which can point to any node. What do you do first? Tell me, why are you in the insert function? Why have you come here? You have come in the insert function so that you can create a node. So there will be a malloc statement. Malloc will create a new node somewhere in the memory. Maybe the address is 6000 at which it is created. So temp will store 6000. Temp will point to the new node. Now this new node is having two members, data and next. So temp arrow data will be made 60. That's the value we wanted to insert. And temp arrow next will be made null. That are the two lines that we saw three times. Now the if statement is going to check if first is null, check the if. But first isn't null. First is pointing to the very first node. So else runs. Else runs. And in the else, notice, in the else we use a pointer called a. And responsibility given to a is a, you start from the first node and go up to last node. Please tell me where is the last node. This is the request made to a. So a equal to asterisk p means a begins with first. A equal to first, isn't it? A points to the same node where first points. And then we hang on in the while loop. We say while a arrow next is not null. You observe right now, a arrow next, this next we are talking about is not null. True condition. So the while executes and it says a, you better point to the next node. A is equal to a arrow next. So a will not point to the current node, but a will point to the next node. I hope you got this again. So a will point at 20, the next node. The while rechecks the condition again. While a arrow next not null, which is still true because a arrow next means 20 is next, is not null. So a will point wherever a arrow next points, but a arrow next points to 30. So a discontinues to point to 20, but a points to 30. And this goes on. While will again say yes, a arrow next is not null. So a will not point at 30 anymore, but a will point to 40. And then while will again say a arrow next is still not null, 40 is next is not null. So a will point to a arrow next, that is 50. And then while says enough, a arrow next is null now, 50 is next is null. So the while breaks. And after the while, we are having a arrow next equal to temp. Listen, a arrow next equal to temp means a arrow next pointer, the pointer next to 50 should point wherever temp is pointing, but temp is pointing to 6000. So so a arrow next 50 is next should point to 6000. That means 50 is next is literally going to store 6000. And that's it. After this a arrow next equal to temp, else and insert ends. Notice that 50 has been attached to 60 and 60 is next is null. So 60 has become the last node now, isn't it? Also, all these garbages, it is so unfair to call these garbage now because they were so helpful. But once the work is over, we always call them garbage. These are of no use. These were local. So all these pointers, local parameters will be readily destroyed. And look, we are having a wonderful linked list with 6 nodes. I hope you have understood the insert function in and out. See you in the next video when we will learn how to display this linked list, how to display 10, 20, 30, 40, whatever is stored in the linked list from first node to last node, how to display it. Thank you very much.